Hi everyone. In this video, we will be discussing about matrix multiplication. It's a lab program 6. Before discussing about the lab program 6, let us try to understand mathematically what is this matrix multiplication and how this matrix multiplication happens. And then we will be proceeding with writing a program for matrix multiplication by using C programming language. So the matrix multiplication means how it happens. Let's try to understand. First, we have to take two matrices which need to be multiplied. So I'll be taking a matrix 1 here and I'll be taking a matrix 2 here. So we can give any name for the matrices. Here I'll be taking it as matrix A and I'll be taking this as matrix B. Now, matrix 1 I'll be taking with two elements in the first row and two elements in the second row. Similarly, I'll take some two elements here. Okay, two elements in the next row. These are the two matrices which I am taking for the multiplication. The first and foremost thing what you have to check for matrix multiplication is, so what's I can say the size of this matrix is, it is 2 cross 2 and the size of this matrix is also 2 cross 2. So now you need to understand when you have to perform this matrix multiplication, the column 1, this is called as column 1, this is called as row 1. I'm considering this as row 1 and this is as column 1. And this is, I can say it as row 2 and this is column 2. So column 2 of the matrix 1 should be equal to the row 2 of the matrix 2. If this condition is true only, I need to perform the matrix multiplication. Otherwise, matrix multiplication is not possible. So that means this should match with this. If these two are equal only, then only we can perform the matrix multiplication. Otherwise, it is not at all possible to perform the matrix multiplication. In this case here, the column 1 is equal to row 2. So it is satisfying. That means I can perform this matrix multiplication. So let's go and see how this matrix multiplication can be done. How this matrix multiplication can be done. Now, so let's create another matrix called as matrix C. I need to create the matrix C. And what should be the dimension of this matrix C? When these two elements are being multiplied, I'll be getting the matrix of size R1 cross C2. That means this R1 cross C2 matrix I'll be getting. So I need to create a matrix C, which is of size rows present in the matrix A and columns present in the matrix 2. So the number of rows present here is 2 and the number of columns present here is also 2. So this much size matrix I need to create, which is called a C matrix, or you can name it with any name, no restrictions on that. Initially what I'll do, so I'll fill this matrix with zeros and I'll try to perform the multiplication and I'll try to replace these zeros with that particular elements which are present in this after multiplication. So now let's see how this multiplication can be performed, and this is not optional. So this is not mandatory that you need to fill with zeros. Since we are performing in the programming part, I'll be doing that. Now let's mathematically do how this multiplication happens in the C matrix now. So the first row of, I can say, A matrix is multiplied with first column of the B matrix. This is how the multiplication happens. I'll take the first element. The first element is 1. That is multiplied with 3. 1 multiplied with 3 plus 2 is multiplied with 7. 2 is multiplied with 7. Again, similarly, the first row is multiplied with the second column of the matrix B. The first row is 1 multiplied with 4 plus again 2 is multiplied with 5. 2 is multiplied with 5. This is the second element of your C matrix. Similarly, the second row of A matrix is multiplied with first column and second column as usual. So 3 multiplied with 3 plus this 4 is multiplied with 7. So 4 is multiplied with 7. Similarly, the second row is multiplied with second column as well. 3 is multiplied with 4 plus 4 is multiplied with 5. So this is my final matrix which I'm going to get. If I calculate, I'll be getting the answer. So let's calculate it and see how do we get this answer. Now we will see this. It is 3 plus 7 multiplied by 4 is 14. Similarly, here 4 is 4 plus multiplied by 2 multiplied by 5 is 10. And here it is 3 multiplied by 3 plus 4 multiplied by 7, 28. 4 multiplied by 3 is 12 and 5 multiplied by 4 is 20. So now the final answer or the final matrix will be, I'll be writing it here. The final matrix is here 17 and here it is 14, and here it is 37 and here it is 32. So this is how the final matrix we will get and this is how the matrix multiplication is done. Now you can check the final matrix which I got is of the size row 1 and column 2, 2 cross 2 only. Row 1 is 2 here, row 1 size is 2, that is row 1 in the sense I can say it as the matrix 1's row size is 2, the matrix two's column size is also 2, so I'm getting the final matrix as 2 cross 2. So that's how we perform the matrix multiplication. And now we will apply this matrix multiplication in C programming language. Then we will try to understand how we can perform this with C programming language. How do we take this particular indexes and how do we go across multiplication? I'll be showing you with C program. So you can see in this program, what they have asked is write a C program to find the matrix multiplication of two matrices, sorry, multiplication of two matrices of size R and C. R stands for row and C stands for column. You need to understand the input and output formats. The first line of the input contains an integer R and integer C representing the number of rows and number of columns. Again, R and C contains the integer numbers representing the matrix 1, and the same is repeated for matrix 2 also. And then we need to perform the final output after multiplication. Let's see the test cases, then we can understand. So the first input is for, I can say, row size and column size of the matrix 1 and the elements of the matrix 1. Again, the next is row size and column size of matrix 2 and the elements of matrix 2. Then we have to print the matrix 1 and then we have to print the matrix 2. And after that, we need to print the multiplied matrix, the result matrix. Let's start coding for this. First, I'll be starting with the taking the inputs. First, we'll include all the header files which are needed. Now, I'll be using the main function, and within the main function only, I'll be performing all my operations. First, I'll declare row 1, which is for, I can say, R1 for row 1, storing the row size of the matrix 1, and C1 for storing the row size of matrix 1 again. So now I'll read both of that. So I'll just give a scanf function. And since the input is given in the same line, I'll be reading it in the same line. So I'll be reading the row size of the matrix 1 and the column size of the matrix 1. Now after that, I need to read the matrix. So for that, again, I'll be declaring two index variables, I comma j. So I'll be using two for loops since it is a two-dimensional array. Matrix is a two-dimensional array. I'll be using one index for moving across the rows and one index for moving across the columns. So I'll say this should be less than a row size, and I'll be incrementing it. Already we know about it. This row is for moving across all the rows, and this index which I'm writing is for moving across all the columns. I'll just increment it. Sorry, it should be C1 since it is column size of the first matrix. So I'll be giving it a C1. And inside this, I need to read the elements. So how do we read the elements? I'll just give format specifier. Since I'm reading the integer elements, I'm giving the format specifier as percentage D, and then I'll be reading all my elements into the matrix. So the matrix I did not declare yet. So after reading these elements, I need to declare a matrix. So I'll be declaring the matrix A now. The size is R1 and C1. So the number of rows followed by number of columns is the size of it. So I'll be giving it as A of ij. A of ij. And we know how it works. I'm not explaining all these things in detail again because how this reading of the elements works, we have discussed in the class. So again, in the previous sessions, so I'm not discussing it again. Now again, I'll be declaring one more variable, another two variables for reading the row size and column size of matrices 2. I'll be naming it as R2 and I'll be naming it as C2. So R2 stands for row size of matrix 2 and C2 stands for column size of matrix 2. Now I'll be reading it. So for that, I'll be using the scanf function again. Let me read these two elements. So I'll just give, I'll store it into the variable called as R2 and C2. Now I need to declare another matrix called as B, and I'll be specifying the sizes R2 and B2, sorry, R2 and C2. Now we need to read this matrix, the same loop which I have declared here. I'll be using the same loop again. I'll be using the same loop again. Now I'll be reading the elements into the B, and my row size is R2 and the column size is C2. The same way how we read the matrices 1, I'm reading the matrices 2 now. After reading the matrix 1 and matrix 2, so then what is our task is, we need to see, according to this, first we need to read the size of the first matrix, and then we need to read the first matrix elements. Then size of the second matrix, and we need to read the second matrix elements. That is what I did. So first matrix, size of the first matrix, then I declared the first matrix, and then I have read this first matrix. Then the size of the second matrix, then I have declared the second matrix. I read the second content into the second matrix, and size is going up to the row size of the second matrix and column size of the second matrix, and then I read the elements into the second matrix now. After that, they want us to print in the program. They have asked print the matrix 1 and print the matrix 2. So let's do that. So it is as simple as that. So first we need to print matrix 1. So that is just a string. I'll just print that first, matrix 1. So I'll say colon, and new line character is also expected there. So next we have to print this matrix. So to print this matrix, I'll just use this for loop which I have discussed previously. So the same matrix. So instead of reading now by using the scanf, so I'll just put it as printf. I'll just give it as printf. So percentage d. So what I need to print now, the content of the first matrix. First matrix is stored into the variable called as array called as EA. So I'm just printing EA of ij. And after every element, there should be a space. You can observe that the first element space, second element space. So I'm giving the space after the first element. And then after completion of every row, we need to give a new line character as well. So I'm just using new line character as well. So this is to print the matrix 1. Similarly, I need to print the matrix 2. I'll copy the same content. There is no change in that. Only the loop or the variables we are going to change. So I'll change this to matrix 2 now. And instead of going up to row 1, I'll go up to row 2. And the size of the column is C2. And I'll be printing B matrix now. That's it. So now let's see whether this works or not. And then I'll go for the performing the operation of matrix multiplication. So let's see whether it works or not. So it is showing that there is an error in the line number 21. Let's correct it. So printf spelling I have missed. So it is printf. Let's say it is printf again. So now we'll run this again and see. There is an error, we'll correct it. So it is asking for the input. I'll say 2 cross 2. So I need to give the matrix. So the matrix I'll give it as 2, 3. So I'll give elements one by one, or else we'll give elements together. 2, 3, and other one is 4, 5. So it is asking for the input for matrix 2. So I'll give the input for my next matrix. Again, I'll give 1, 3. Again, I'll give 5, and I'll give. So it is taking in a different way. So let's rerun it and check. Is there any mistake in our code? So I'm giving size is 2 cross 2. So I need to give the elements 2, 3, and then I'll give 4, and I'll give 5. This is my first matrix. Again, second matrix size I need to give. Second matrix size also I'll give 2 cross 2 only. Again, now I'll specify second matrix elements 1, 3. So randomly I'm giving. I'll give 5 space 1. So it should print as it is. Yes, so matrix 1 it is printing as it is. You can see 2, 3, 4, 5, and second matrix is also printing as it is 1, 3, 5, 1. So it is correct as of now. Whatever the program we did, it is correct. Now we'll go for the multiplication operation after this, after the completion of printing of the second matrix. Now I'll go for matrix multiplication. What they say is, so the first condition you can observe here, the first condition what I discussed was, so we need to check whether the column size of the first matrix is equal to the row size of the second matrix or not. I'll put that condition first. So that means C1 is equal to R2. If this is condition, if this condition is true only, I need to perform the matrix multiplication. Otherwise, I need to say multiplication is not possible. So I'll write the else case first. If this is not true, I'll write the else case saying that matrix multiplication is not possible. So this is what in the second test case they have asked. You can observe here matrix multiplication not possible. So I can say multiplication not possible. Multiplication not possible. So if this condition is not true, in the else case, I'm writing that multiplication is not possible. Suppose if this case is true, inside the if condition, I need to perform the matrix multiplication. This is what I told. Column size of the matrix 1 should be equal to the row size of the matrix 2. If that case is true, then I need to perform the multiplication here. So let's go inside this matrix. Let's go inside this matrix. I'll declare one more, I can say, uh, C matrix. This is what I have discussed there, C matrix, and the size of the C matrix should be row 1 size of the matrix 1 and column 2 size of the matrix 2. This is what I have discussed in the previous session, in the previous discussion here. So now I'll just use a loop to move across. I'll declare one more loop indexing variable called as K as well. I'll tell you why it is. Okay, so now I'll be using a loop as usual. Since the size of this matrix is R1 to C2, so I need to write this number of rows to move. It should move across all the rows present in the matrix 1. So I'll be writing I equal to 0. I should be less than R1 and I should be incremented. Similarly, column should move up to the j number of columns. So the column should move up to the j number of columns. This is what we have discussed here. I think I'll be showing you in the whiteboard. You can see in the whiteboard the size. See, it should move to the number of rows present in the matrix 1 and number of columns present in the matrix 2. So that's why I'm writing my loop here as R1, the first loop across R1, and the second loop will be up to number of columns present in the matrix 2. That is what I was doing there. So let's try to write that here so that you will have a clarity on this. Now, so the for loop I'll be writing. So J loop should be initialized to 0, the column. Number of columns should be up to the columns present in the matrix 2. So, and again, J I'll be incrementing. So first what I'll do inside this for loop, I'll just initialize my C of ij to 0 in before multiplication. Before multiplication, all the elements of my C of ij, I'm making it as 0. And inside this, I'll be using one more for loop. Inside this, I'll be using one more for loop, which is called a scale loop. I'll be explaining about this. Just I try to understand. And I'll be moving this k up to the size of, so you can understand through this. You can understand through this. So what should be the size of this particular k loop? See, you can understand size of the k loop will be either the size of the column 1 or it should be the size of row 2. I'll explain about this. So first let's write the code and then we'll come back and we'll trace here. It should be, I'll be saying it as size of the column 1 and I'll be incrementing the k value. And inside this, I'll be writing a small logic which you have to understand here. So I'll write C of ij plus equal to, that means it is added with. So I'll say A of I and k multiplied with A of ik multiplied with B of kj. This is the logic which I am writing here for multiplication purpose. This is the logic which I am writing for multiplication purpose. So let's try to understand this concept there. I'll just take this code and we'll go to our, I can say whiteboard, and we'll check in the whiteboard how we can understand this particular concept. Let's try to understand this concept now. I'll take this example only. Now let us take this example and I'll be pasting my code here. Okay. So let's see, initially I value is 0. So we know C we have defined. So let us assume this is C of 2 cross 2. Let us take C1 value is also C1 value, R1 value is 2 only, and again C2 value and R2 value is also 2 according to this particular example. Now let's say I value is initialized to 0. Initially I value is 0, which is less than 2. The condition is true. It will enter into the loop. Again, j value is initialized to 0. So j value is also 0, which is less than 2. The condition is true. It will enter into the loop. Now initially C of ij value, I am making it as 0. This is called a C matrix. C of ij value is 0. Again, k value I am initializing to 0. K is less than C1. So C1 is again 2. K value is less than 2. Okay, you can understand that. Now we'll enter into the loop. Inside this, what I am doing, C of ij will be equal to C of ij plus A of ik. What is I value now? What is I value? It is 0. What is k value? K value is also 0. So that means 0 comma 0. So the element will be picking this particular element. So C of ik, A of ik value will be equal to 0 comma 0 value. So it will take this particular value plus here 0 plus A of ik value. A of ik value is 1. 1 is multiplied with B of kj value. What is B of k now? K value is also 0 and j value is also 0. B of k value is also 0 and B of 0 comma 0 means this element it will take and it will multiply that. So it becomes 0 plus 1 multiplied by 3. So 1 multiplied by 3 becomes 3. So that means this answer is replaced with, this answer will be replaced with 0 plus 1 plus 3. So I'll just continue this. We'll come back to this particular discussion later. We'll continue this again. Plus this is again added with, again, so okay, this operation is done. K value will be incremented. So what is the C of ij value now? C of 0 comma 0 is 1 multiplied by 3, that is 3. Its answer is 3. This will be completely summed and will be stored into C of ij. I'm just keeping it for your understanding purpose like that only. Just I wanted to make you understand how this particular loop works. Now again, k value gets incremented. See, innermost loop is k value. So k value did not terminate yet. K loop did not terminate yet. So k value will be incremented. So previously k value was 0. Now k value will become 1. 1 less than 2 because C1 value is 2. So 1 less than 2, the condition is true. It will enter into the loop. Now we have to do A of I k. What is k value? I value is 0 only. I value is 0 only. J value is also 0. But k value is 1. A of I k. So that means 0 comma 1. A of 0 comma 1. What is 0 comma 1? 0th row first element. So 0th row first element is 2. It will take 2 multiplied with B of kj. What is k value now? K value is 1. What is j value? J value is 0. 1 comma 0. This particular element is 7. It will take 7 and multiply. That's why we are using this particular k loop. Please try to understand. K loop is used to move across these particular elements. The rows from here and the columns from here. To move across these elements, we need to use this particular k loop here. And this k loop can be either the size of column 1 or either the size of row 2 because both are same. If they are same only, we can go for the multiplication. Otherwise, we can't go for the multiplication. Now, again, k value gets, this is what we did. Now, b of 1 comma 0, that is first row's 0th element, that is 7. We have taken 7 and we have multiplied. After this, the result will be stored into the, again, C of ij that we know. K value gets incremented. K value becomes 2. 2 less than 2, the condition is false. When the condition is false, again, it will go back to the next innermost loop, the next higher loop. The next higher loop is j. So j value was initially 0. Now the j value gets incremented to 1. Now the j value will become 1. I value is 0 only. J value becomes 1 now. So after j value becomes 1, again it will enter into the loop C of ij. What is ij is nothing but now C of 0 comma j value is 1 now. C of 0 1. So that means C of 0 means 0th row first element at this particular location. Now I need to calculate the element. What happens again? K value is initialized to 0. K is less than C1 value. C1 value is again 2. So condition is true. It will enter into the loop. C of ij, that means 0 1 is 0 now because I have initialized just now to the 0 here. Plus again what I need to do, C of ik. What is C of ik? So that means 0 comma k value is also 0 now. K value is also 0. C of 0 comma 0, that is 1. So 1 should be multiplied with the same condition which we are applying it again. Please try to understand. C of A of ik is nothing but 1, 0 comma 0. See, I value is also 0 and k value is also 0. A of 0 comma 0 is 1. That should be multiplied with. Now it should, this row should be multiplied with this element, right? You please observe now. Now what happens? B of kj. K value is 0 now and j value is 1, 0 comma 1. That means the first zeroth row first element. The zeroth row first element is 4. It is multiplied with 4. Plus again, plus again. Now again k value gets incremented after multiplication. Again k value, this value will be stored into C of ij. Again k value gets incremented. K value becomes 1 now. 1 is less than 2. The condition is true. Again it will enter into the loop. Now what's A of ik? I value is 0. K value is 1. 0 comma 1 is this element. This element should be multiplied with now again b of kj. What is b of kj now? So b of k value is 1 now. So 1 b of 1 comma 1. What is b of 1 comma 1? It is 5. This is 1 comma 1 in location. That is first row, first column. First row, first column is 5. It will be multiplied with 5. This is how we get the multiplication of the matrix. Again, k value gets incremented. K value becomes 2. K value is 2. 2 is less than 2. The condition is false. So that means it comes out of this particular loop. Again, we'll go back to the j loop. J value gets incremented. So j value becomes 2. 2 less than 2. The condition is false. Again, it will go back to the for loop. I for loop. Now, I value was initially 0. Now, I value will become 1. When I value will become 1. So now the condition is iterated again once again. So the I value is 1. J value will become 0 now. Again k value will become again k value will become 0. So now C of ij also becomes 0. C of ij is nothing but C of I value is 1 and j value is 0 now. That also is initialized to 0. Initially this becomes 0 plus. Now again k value we are initializing it to 0 only. K value is 0. K less than C1 value. C1 value is 2, which is the condition is true. Again it will enter into the loop. C of ij now. C of ij value is nothing but C of 1 comma 0. That is first row, 0th element. This position. This position I need to put my elements now. A of ik. What is I value? It is 1. It is 1. First row. What is k value? 0. 1 comma 0. 1 comma 0 is nothing but 3. 3 should be multiplied with b of kj. What is k value? 0. J value 0. So that means b of 0 comma 0. What is my 0 comma 0? It is 3. Should be multiplied with 3. So see again it is happening in the same manner. This row with this column. Again for the next iteration k value becomes 1. For the next iteration k value becomes 1. K value becomes 1. Now we have ik value is 1 comma k value is 1. So that is 4 multiplied with again b of kj. K value is 1 and j value is 0. So that means, sorry, k value is 1. Again j value is 0. So k of 1 comma 0. So that means first row and 0th element, that is 7. It is multiplied with 7. And this procedure repeats for every element. This is how it works. That's why we are using the k loop to move across individual elements. See, first outer for loop to move across the rows of the column A. Second outer loop is to move across, sorry, rows of the matrix A. And second loop is to move across the columns of the second matrix. Or I can say to store the elements into this particular elements, sorry, into the particular result matrix. And this K is to move across these individual elements in the, I can say, matrix 1 and matrix 2. We are using this particular K loop. And this multiplication happens in this way and we get the appropriate result. So that's why I have written my program there in a way that it goes across every element and takes the every element and performs the multiplication and addition and stores the result into the result matrix called as C. And after this, after the multiplication is done, so I need to print the matrix. So this is what it says, the result matrix we need to print. Result is equal to, I'll just print the result matrix. So I'll say printf. So I'll say result colon, I'll use the new line character. So result matrix we need to print. So I'll just use the same the code. Instead of rewriting it, I'll just copy this for loops and I'll change accordingly how it is needed. So now the matrix, what's the matrix? New matrix size. The new matrix sizes, it should be the row 1 and C2. So row 1 and C2. So I'm printing the C matrix now. So I'm printing the C matrix. So the same way, the result is equal to, I'm going across rows. Row size is R1 because I have declared C. You can observe that C has been declared with row 1 and C2 size. So that's why I'm moving across still row 1 and C2 size and I'm printing all my elements one by one by using the results of C matrix. Now let's submit and see whether it works or not. So it has been successfully submitted. This is the code for your matrix multiplication. This is how we perform the matrix multiplication. Please go through it. If any doubts, you just revert back to me either in the comment box or you can respond to me. So I'll be clearing your doubts. And it has been previously discussed. Still, I'm giving you the brief idea about it. Thank you.